Hi, welcome you again. I'm Sabir Ahmed. Today I'm gonna teach you about spatial analysis. That means how you can analyze your data, especially. In this lecture, we will cover three or four topics: interpolation, contour, surface analysis. So, at first, we will look over what is interpolation and why we will use this and how we will use this. Then we will use contour. What is this? And I will explain this later while I will teach you about that, and then how we can analyze a surface. Okay, so interpolation, the term interpolation may be new to you, but it is very helpful for analyzing a spatial data. If you are if you're from mathematics department, then you do have an idea about that. But if you are not from mathematics department, don't worry about that. I will try to make you understand. I hope you will understand. Okay, so what is interpolation? So from the name, it is very clear that you will interpolate. That means if you have 2 points, then you will predict some values in between those 2 points, right? So this is called the polation between that 2 points. Okay, so formal. If we go to the formal definition to the interpolation, then what we'll see: interpolation is a procedure, that means a mathematical procedure to predict values in places where sample points lack. Okay, I'm gonna make you understand this definition using a figure. Okay, for example, this is a point data. This is a point data surface. This is surface. This is another surface. Okay, this is interpolated surface. This is point surface. Okay, so for example, if you look over this area, for example, there are several points, but in between those points, we do not know what is the value of this. Uh, Otherwise, we do not know this area's values, right? This area's values. But using the interpolation technique, we can get that values. For example, if we look over the interpolated technique, then we will see that we have all the values here. We have all the values here, and we didn't have that. We didn't have this portion's values, but in the interpolation surface we do have all the values, right? And here we didn't have any values, but here we do have values. So this is the interpolation technique that interpolation mathematical technique that we will use for analyzing a surface. So in which case we are going to use this interpolation technique? Especially we're interested in who are working in hydrogeology, who plots frequently the water level, or to understand the extension of borehole location. An interpolation technique is very helpful to understand, to make a representation of the gravity. This is the gravity data of Bangladesh, so I have represented this here. And if you're from environmental analyst, then you can do that, and you can analyze surface using interpolation technique very easily. It is really very helpful. Moreover, it is really helpful for your research paper representation, because you cannot represent this. But otherwise, if you represent this and you can make a figure with this, then definitely it makes more better sound than this, right? Okay, so there are different techniques of interpolation method. As it is a mathematical method, there are different techniques. So we are gonna uh, we are gonna see what are those techniques and how we do that. Okay, so okay, before going to the methods, I'm gonna show you some other interpolation procedures. For example, the interpolated rainfalls are represented by a box. For example, it's 1 and 2, and we do not know the values in between this 1 and 2. So we can easily find it out using the interpolation techniques. So interpolation is a procedure used to predict cell values for locations that lack sample points. So uh, how we can find out these values? Interpolation technique can do that. Okay, using the neighboring points. If we do have these points, these are the neighboring points, right? So we can do that easily. So there are different techniques of. I've got these documents from by Collins Childs, ESR Education Service. So you can get it from internet as well. So there are different the methods of surface representation. Yeah, we have already said that we can make surface using points. Even we can mm, represent a surface using contours. For example, these are the contour lines. What is the contour lines? Contour line is nothing but representing isolines. That means this line represents all the values same. This line represent values having equal values. For example, if this is the elevational map, then this line represents for example, this is the 500-meter elevation, then this line represents all 500 line elevation. And for example, if this line is 200 elevation, then it represents the 200 points also here. Then other methods also, teens, grids. We are not interested about the teens and grids, because in 3D analyst we will discuss more about teens and grids. Okay, so at this moment we are interested about different types of interpolating surfaces. Okay, so there are different types of interpolating techniques. For example, the IDW, kringing, spline, point interpolation, nature neighbor, topo to raster, and there are lots and trend. You can analyze also trend. Okay, so step by step we will at first understand what is IDW. IDW inverse distance weight. Okay, IDW function should be used when set of points in is dense uh, enough to capture extent of local surface variation needed for analysis. The IDW determines cell values using a linear weighted combination set of sample points. The weight assigned is function for the distance point. The greater distance and less the influence the cell has their points. And I'm sure you can understand all of that. And so this is very important for this IDW. So when you will use IDW, you will use IDW when there is a dense points. That means if I go to my slide, then for example this areas have very densely populated points, right? So for this, and if you want minute details, minute analysis, then we can use IDW, because it says when the set of points is dense enough to capture the extent of local surface variation. So if you want or find out the local surface variation where the points are dense enough, then we can use this IDW method. Okay. The another point is spline. Spline is very important, especially if you want some smooth results. Spline estimates values using mathematical function that minimize the overall surface curvature. It minimizes the surface curvature. For example, you will see there are lots of surface curvatures here. But it minimizes here. You will not find this surface curvature here. You will not find any. It is smooth. So the result is a smooth surface that passes exactly through the input points. Conceptually, it is like bending a sheet of rubber so that it passes through the points while minimizing the total curvature of the surface. So if you want a smooth surface, especially it is very important if you want a Rees or Bailey analysis, that you can do that. Not only Rees and Bailey, I've got some noise. I'm sorry, my mom is working over there. Okay. Uh, so spline is like that. So it can predict recent values in the data and the best methods representing smoothly varying surface phenomena and temperature. Varying surfaces of phenomena temperature. There are two variations of spline: regularized and tension. A regularized spline incorporates the first derivative. You understand, dt by dx, or dx by dt, whatever it is. A second derivative, rate of change is in slope, d square dx by dt square. And third derivative, rate of change in the one derivative into the minimization calculus. Although tension spline uses only the first and second derivatives, it includes more points in explanation. Okay, so you understand the objective of this, right? So according to your objective, you can use the method. Another very powerful and important method is Kringing method, a powerful statistical interpolation method used for diverse applications such as health science, geochemistry, pollution modeling. Kringing assumes the distance or direction between sample points reflects a spatial correlation that can be used to explain variation in a surface. Okay, Kringing is the most appropriate when a spatially correlated distance or directional bias in the data is known and is often used for application in soil science and geology. So there are lots of techniques are here, so you can understand. For example, this is the Kringing, and what is the or, and these the same data are represented by the Kringing interpolation method and the Spatial interpolation method. So if you compare these, then what you will see, this is very smooth. This is very, this Kringing method have different curvatures, right? So for larger scale data, we do generally use stringing method. For small scale data, we do use spline, and if you want smooth and non-variational data or surface, then we can use the spline data. On the other hand, for densely points, if you want to understand the local variation of a data, then we can use the IDW. Generally, we do use IDW, King, and spline methods. However, you can also understand, you can also the point interpret, okay, point interpret, natural neighbor, and topo to raster, something like that. Okay, so these are the graph, and from where you can understand um, the different methods get value interpolation. For example, how they can vary. So uh, so from this graph, it is very assumed that we'll get different types of surface if we use different methods, right? So we'll get different types of error in different types of method, right? So uh, don't think that you are going to do 100% accurate thing, because at first I've said that we're predicting values in between two or more values, right? So if we predict some values, definitely there must be an error. So you must have to care those errors. You must have to um, analyze those errors as well. Okay, so these are the things of interpolation techniques. Okay, so now I'm going to ArcGIS 10 to understand the interpolation technique. Okay, so for this is ArcGIS. For your convenience, I've made some surface interpolated surface from some points. Okay, I'm gonna take this off. I have data of here. So what I have this, so this is the contour data of my contour data of gravity anomaly of Bangladesh, northwest Bangladesh here. So what does this line mean? This does mean this line represent a same value. Okay, so for interpolation, what I've said, we want to predict unknown samples values, right? So for interpolation, we have to use point, right? But we do have line data. So how we can convert this line data into point data? So that is easy technique. We can do that. That is a uh, tool from the data management tools. If you go to the feature, then we can go to the feature vertex to points. So from these tools, we can convert this line data into a point data. So you cannot use the line data for interpolation technique, but you have to use the point data. Okay, I've converted. So point type all. So that is need, start, and both ends, the angle. So you can use, however you want. Okay, but we do generally use all point type. So that we can get all the points of line, not from start, not from middle, not from end, something like that. Okay. Okay, and we have got the same, we have got the points. For example, if you see that uh, points here, we have got the points from the line. So using this point data, um, I can interpolate this surface. For example, using this point data, I have interpolated this spline. So so these are the point data, and from the point data I have got a surface, and I've also got a Kringing here, and this is the IDW. Okay, so I'm gonna show you how I've used the three different methods: spline, clinging, IDW. So this is the spline method, right? So I'm gonna show you how this methods, this means spline, clinging, and IDW varies from each other. For example, if I take this off, then you will see a great variation, right? And I'm gonna show the variation between spline and clinging. So you're seeing the spline methods. For example, if you look here, then what you will see, there's a great variation, color variation as well, right? You can see the smooth variation. Um, these are the clinging method. So more curvatures here, and in spline methods, you'll see more smooth than this, right? Okay. So if we use the clinging and IDW variation, then you will see also the same thing. There are lots of variation. So depending upon your purpose, you can use any of the methods or use all of the methods and then uh, analyze the difference between this. Okay, so uh, I'm going to show how to make an interpreted surface. Okay, sorry, I had to go. Okay, we have seen the difference between the different methods of interpolation techniques. Okay, now I'm going to show you how we can make a, uh different interpolated surface. Okay, so you have to go to catalog, then we have to go to the spatial analyst, because today's lecture is called spatial analysis. Okay, so from the spatial analyst tool, you have to go to the interpolation method. Interpolation, so there are different interpolation techniques: IDW, clinging, natural neighbor, spline, uh, spline barriers, topo, raster, trend, something like different things. Okay, IDW. So input features, there are two types of features. Number one, line and point. Let's see which features are selected by here. Yeah, only point data. So GP is the point data, right? So in interpolation technique, you have to use only the point data to interpolate those. Okay, so you have to use the interpolation technique. So jet value, so in which value you are going to interpolate, it may be elevation, it may be a depth, it may be the temperature variation, it may be the any kind of variation that you want. Here I am using the Booger gravity anomaly. That means the gravity variation of this region, how gravity varies in this region. Okay, so you do not have to change this, these are automatically done. An output raster, so you can change your output. So I have already made another IDW. Okay, IDW, it don't was already taken IDW1. Okay, IDW1. So I've already done this method. So if you don't have to change all other things, there's some variables, search radius, peaks, or something like this, number of points. So if this is not variable, then you can do that. A variable, then for example, what is the variable? Search radius variable. For example, if you want a prediction, if you want a prediction of a region, then it will take counts fixed number of points. Okay, so according to your definition, right? Distance, in this distance, it will count only, it will never go beyond this. But if you use the variable, then it will be more perfect. Okay, if you press OK, then you will get IDW interpolation technique. Yeah, so I've got this IDW map of this. Okay, so in similar way, you can do that clinging, spline, natural neighbors. Okay, so what you can do, there are huge research options here. Okay, if you're from mathematics or if you're from non-mathematics, it doesn't matter at all. What you can do, you can find out the different interpolation techniques. You can use different interpolation techniques, and you can find out the errors of different interpolation techniques for a particular region. So you can analyze, for this research purpose we have got these errors for this method. Okay, so for this kind of analysis we can use this method, and this method seems very well for this analysis, and this method doesn't seem. Okay, This is really very important for you to understand the process. Okay, so we are already end of our interpolation technique. Okay, so we can, so I'm sure you understand this process. Okay, we are switching to another tool, to surface. This is the surface, right? So if you want to analyze this surface, how this surface or how the gravity values of this region varies, right? So we can do that using the surface tools. There are several tools under the surface: aspect, contour, contour list, contour with barriers, curvature, cut, hillshade, slope, and I make you understand step by step. So what is aspect? Aspect is nothing. From the aspect, we can easily understand. It means the direction. That means this is an anomaly. This is an anomalous value, right? So how the values are directed in this region. Okay, contour, we can make a contour. That means the isolines representing the same value. The contour list, curvature, how the anomalous are carved here. Hillshade, three-dimensional representation of the hillshade. Slope, so we can understand how the values are sloping here. What is the slope of this region, right? So we can easily do that. Okay, I'm gonna take some break right now, and I'll come back soon. Okay, welcome again. So we are here. Okay, aspect, contour, contour list, slope, something like that. So we can easily, and so we'll see the aspect of spline, clinging, and IDW. Okay, so how aspect will varies, and we can see that right now. So if we find out the aspect of spline, then okay, let's see how we can do that. Let's say aspect spline. Okay, then we can do that. Aspect. We're getting this, the aspect of the spline. So we have got the flat, not east, east, west. So how the anomalies of this region varies with direction. Then if we find out this, we can use the aspect. Okay, so this is the aspect. So if you want to find out the contours, then okay, let's see spline to intersect the contour. So contour interval. So what is the variation? The highest value is 128 and the lowest value is minus 177. So what would be the contour? Where contour interval? So contour interval, let's say 10. It means that we'll get the lines interval about 10. Okay, 10 contour interval. So this is the contour. So contour will be the shape file, not the raster file. Okay, that's why it's called feature class. Okay, contour. So if we yes, okay, then what we will see. Yep, we have got the contour lines. For example, this, right? So this value represents the value, and this will represent the value, and having interval of 10. This line and this line representing 10. Okay, so these are the contour lines. So for example, here the contour values are very prominent, and can you please tell me why? Because the data variations are here is very good here. So you can do that here. Uh, this is the contour value. So you understand what is the contour value? Okay. Catalog, contour value, curvature, slope. You can also find out the slope. Slope of the spline, for example, spline output. This is the slope. Yes, slope. Slope here. So what would be the unit? So percent rise or degree. So we put degree. Let's see how slope. That means how it varies. Yeah, it varies like this way. So we can now we can easily do that. Uh, This is the slope values of that of this region. So how the slope of this surface varies. So you can do that easily. Okay, you can do that easily. Contour value, surface, or something like that is very important. Okay. Okay, so this is the slope of this region. How gravity of this region is varying? What is the slope of this? So we see slope of this region is very negligible especially in green area. So we didn't find any slope. So here, especially in this portion, we found that this thing. So why we do use slope? We do use slope to understand where the slope is maximum, and we can understand why the slope is maximum. So this is the clue. This is understand. So in this area, slope is more or less very good, much more than these areas, right? So this is very interesting. Why the slope? That means why the variation of this is variation is distinct and is mass. So this can be a clue. This can be a way to go further analysis for further analysis, right? So for example, this. Okay, so this is the slope, and this way you can do hillshade and contour list or something like that. So this is very basic thing of spatial analysis. So I hope you have understood what I have tried to make you understand. Okay, so thank you very much for being with us. I hope you understood, and write comments if you do not understand anything, and write in Facebook if you don't understand. Thank you very much for being with us, and I hope we will see you in next video.